Welcome, Deep Diver. Today, we're diving into something huge. It's this massive global plastic problem that honestly can feel a bit overwhelming sometimes.
You really can.
And here's the interesting part. We've got some sources pointing to a scientific discovery, something really fascinating that maybe could actually be a game changer.
Mm.
So this deep dive, we're going to unpack your materials on this, really get to the heart of what this breakthrough might mean for the planet and, for you.
Right. And it's important to frame the scale here. We're talking about an enormous challenge, this flood of plastic. It's everywhere.
Yeah.
But what's compelling about this discovery is the real tangible hope it offers. It's kind of a testament to human ingenuity, finding solutions even when the problem seems insurmountable. And we'll explore why that matters so much.
That urgency is definitely there. I mean,
Yeah.
when you look at the numbers, the sheer volume of plastic waste,
Right.
it's kind of staggering.
It is.
We're talking, what, 9.1 billion tons globally
Yeah.
already out there?
Yeah.
And the really chilling figure for me is the 19 billion pounds ending up in our oceans every single year.
19 billion. It's hard to even picture that amount.
Really is. It's like, imagine dumping the weight of everyone in New York City into the ocean twice every year.
Yeah.
That's the scale we're dealing with.
And that sheer quantity, it leads directly to some really devastating consequences. Millions of marine animals dying each year because of it.
Terrible.
But what's often missed, and maybe even more unsettling, is how it circles back to us directly.
How so?
Well, once plastic hits the ocean, it starts breaking down into these tiny pieces, microplastics. Marine life eats them.
Ah.
And then it works its way up the food chain, right onto our plates, essentially. The sources show this pretty clearly. Plastic's been found in human stool samples, even inside our gut.
Wow. So it's literally inside us.
It's become that pervasive, yes.
And the urgency just ramps up when you think about how long this stuff actually lasts.
Yeah.
A regular plastic water bottle,
Yeah.
the kind you might grab without thinking.
Takes ages.
Around 400 years.
Yeah.
400.
Yeah.
And those little plastic straws, maybe 200 years. So it's not like it just goes away. It just piles up
Yeah.
for centuries.
Exactly. It accumulates. It outlives us by generations. Which really begs the question, right? If it's so bad, why do we use so much of it?
Yeah. Why are we so hooked?
Well, what the sources point to is this powerful mix. It's convenient, it's cheap, and it's lightweight.
Right. Think about it. Ziploc bags, water bottles on the go, grocery bags.
Plastic plates for a party so you don't have to do dishes.
Yeah, exactly.
Yeah.
And the insight isn't just that it's convenient, it's how deeply ingrained that convenience culture is. It's almost like a societal habit, maybe even an addiction. Makes changing things way harder than just finding an alternative material.
Absolutely. It's systemic.
And the consumption rates right now are just, well, alarming. Globally, something like 20,000 water bottles are bought every second.
Every second.
Yeah. And every minute, a million are produced. A
Yeah.
million. And here's the real kicker. Only about 10% of that actually gets recycled.
Only 10%.
The rest just adds to that accumulating pile we talked about. Landfills, oceans, somewhere.
Which, brings us neatly to the more hopeful part of the story. Despite this enormous scale, this is where science really starts to offer something interesting.
Okay, yeah. Because with a problem this big, you really need something significant. So where did these potential solutions start? What was the spark?
It actually started with some incredibly diligent researchers in Japan, just pure scientific legwork.
Oh, yeah. What were they doing?
They spent 5 years, basically digging through garbage, mountains of it.
Literally digging through trash.
Literally. Their goal was just to observe, to see if nature itself was maybe adapting or responding to all this plastic waste.
That's dedication. So what did they find in all that digging?
Yeah.
Anything useful?
Amazingly, yes. What's fascinating is they found a specific strand of bacteria, and this bacteria had actually evolved on its own to eat polyethylene terephthalate.
PT. That's the stuff in water bottles, right?
Exactly. The most common type used in bottles, packaging. It was like nature finding a new food source in our waste, a natural evolutionary step.
Wow. Okay, so bacteria that eats plastic.
Yeah.
But how well did it work? Was it like a super fast solution right away?
Not quite, not initially. It could break down thin layers of PT, sort of munch on it, turn it into smaller pieces, but it didn't fully consume it, and it was slow, like 6 weeks slow.
6 weeks for a thin layer.
Yeah, so definitely a groundbreaking discovery, finding it at all, but clearly not fast enough to tackle the, mountains of plastic we have.
Right. Okay. So the original bacteria was a bit sluggish.
Right.
What happened next? Did they genetically engineer it to speed it
This
up?
where things got really interesting, where collaboration comes in, and actually a bit of luck.
Luck. in science.
It happens. So, scientists from the University of Portsmouth in the UK teamed up with the US Department of Energy's National Renewable Energy Lab,
Okay.
and they focused in on one specific part of the bacteria, a particular enzyme. Enzymes are like nature's catalysts. They make biological reactions happen, break things down efficiently.
Right, the things that do the actual work.
Exactly. They wanted to study that enzyme, understand how it works.
So they're studying this enzyme,
Mhm.
and then what? How do they make it better? Was it years of careful tweaking?
You'd think so, right? But this is the happy accident part. They were actually just trying to modify the enzyme slightly so they could get a better look at its structure using X-ray technology. Standard procedure, really.
Okay.
But in doing that, they accidentally created a version of the enzyme that was about 20% more effective at breaking down the PT plastic.
Wait, really? They made it better by accident?
Yeah. Suddenly, this modified enzyme could break down the plastic much faster in a matter of days, not weeks.
That's incredible. From weeks to days, just by chance.
It was a huge, unexpected leap forward, serendipity at its finest.
So that brings us to now. We have this super enzyme. Is it ready? Can we just, unleash it and solve the plastic crisis tomorrow?
Ah, if only it were that simple. Unfortunately, no, it's not quite the magical cure we might wish for.
Okay, why not?
Well, while it's incredibly promising, the technology is still very much in its early stages. Researchers are still working on it, tweaking it further, trying to make it even more efficient.
Makes sense.
And crucially, they need to figure out how to scale it up. We have so much plastic out there, you need a process that can handle massive volumes cost effectively.
Right, efficiency and scale. Got it.
And even then, it can't just magically undo all the pollution that's already out there, especially the stuff deep in the oceans or broken down into microplastics everywhere. And maybe most importantly, it can't solve the problem if we just keep producing and consuming plastic at the current rate.
Ah, okay. So it's not a silver bullet. That feels like a really important point. This enzyme, it needs help, doesn't it? It ties back to what you said earlier about our habits.
Precisely. It comes down to prevention and our behavior as consumers. As long as we keep demanding single-use plastic, companies will keep making it. That cycle just continues.
So the enzyme can help clean up, but we have to stop making such a huge mess in the first place.
Exactly. You have to break the cycle. This enzyme is a fantastic tool, potentially, but it won't work if the demand for new plastic just keeps growing. It needs us, individuals, to change our part of the equation.
And that's really where you, listening, come in. You can actually help this enzyme, help its mission succeed, just by making different choices. Small things, really. Like using a reusable water bottle instead of buying plastic ones, taking reusable cloth bags to the grocery store, maybe using real plates instead of plastic ones for that party.
Even just being more diligent about recycling the plastic you do use if it's absolutely necessary. Every little bit helps reduce the amount this enzyme or any future solution has to deal with.
Right. Make the job easier for the science.
And there are real personal benefits, too, beyond just helping the planet, which is huge, obviously.
Oh, boy.
Well, you're actively reducing your own environmental footprint, which feels good. But also, remember those microplastics we talked about finding their way into us?
Yeah.
By reducing your plastic use, you're also helping safeguard your own health, minimizing your exposure to potentially ingesting those particles.
That's a really good point. So it benefits the planet and you directly.
Definitely.
Okay, so wrapping this up, the core message here, the main takeaway from this deep dive seems pretty clear. We have these amazing scientific innovations like this plastic-eating enzyme offering real hope, which is fantastic.
Huge hope.
But they're not going to work in isolation.
No.
They're most powerful, most effective when they go hand in hand with us changing our habits, our choices. It's got to be both.
Absolutely. It's a two-pronged approach, innovation and prevention. Science gives us tools, but we need the collective will to use them effectively and, crucially, to reduce the need for them in the first place.
Right.
And maybe stepping back, here's something for you to think about. We've seen how much our desire for convenience drives this huge global problem, the plastic mess.
Convenience is powerful.
It really is. So the question to ponder is, where else in your life, beyond just plastic, might making small intentional changes, maybe sacrificing a tiny bit of that convenience, lead to a massive positive impact on some other big global challenge?